Oh, I know. Here, let's zoom in. It's rotating just on the wrong axis.
Oh
But
no.
this is the last stream of 2020.
The last possible one, we really kind of snuck it in there. What does your shirt say?
Oh, it's like a read-in chart of New Orleans street names. Like an
Oh,
eye chart,
like an
top to bottom.
optometrist thing.
And it turns out it mostly looks like nonsense letters because our street names are mostly nonsense.
Give me an example.
Chapatulis, which like not nonsense. I think it's actually the name of an Indian tribe, but I think it's like a anglicized version of another name we've heard and just like stuck some letters together.
Got it. Yeah.
Yeah. So like the Chapatulis tribe is real, but like I don't think this is the alphabet they use to say their name.
Where is my brain?
Where's your brain?
I don't know. I was actually just working on the game before. I think my brain is still there.
Fair enough.
It does seem like you got into Opus Magnum a bit.
Dude, I like it, and the story is weird.
Yeah, but it's funny, right?
It's really cute. Yeah, I like you were right that the way they like sort of deliver the little snippets and the little Harry Potter-esque alchemist thing is cute.
Yeah.
Yeah, very very fun, and also basically just Space Chem Take Two, which was great.
Yeah, I don't think Space Chem has much of a plot line except that you're just like working, basically.
You're like doing your job in space. Yeah, you are a pharmaceutical employee.
Yeah.
In space.
And then like after Opus Magnum, it was just like 3 games in a row where they just decided, you know what, all we're really doing is like assembly programming, so we're just gonna like literally have you write assembly program. And so that was TIS 100, which has no storyline. And
None.
then
Oh wow.
Shenzhen IO, you're like just like electronics designer living in Shenzhen. And then there's Exapunks. And
I think Exapunks is like one of the cooler looking things too.
Yeah, it's funny. For each of those games, I hit a wall. Actually, for every single Zachtronics game, I hit a wall where I was like, I don't know if I can quite push through this one. Base Chem, it was just because it was like too hard. And then
Space Chem got really hard.
TIS also gets hard. And then what else am I thinking of? Shenzhen IO, they're part, like Exapunks got to a point where it got kind of got silly. It wasn't hard so much as it was silly.
So is this like, are you a hacker in this tiny like cyberpunk microcomputer world?
Yeah, that's cyberspace. And you control you write little AI brains for these little bots, and they have to like navigate a space and like pick stuff up.
Oh, cool.
Yeah. And
with assembly.
Yeah, and it uses assembly language to kind of like pick up and drop things. You know, it's a little bit like the Opus Magnum ARMS, only you're navigating a space. I think the thing that I got blocked on was like you had to like actually fight other robots.
Oh wow, so it's like the elevator AI game where you're like writing elevator AI because you're just writing like some game AI.
Oh, good lord! What is the elevator AI game?
Elevator AI game. I mean, it's exactly what it sounds like, which is you just program a function that moves this elevator up and down like as efficiently as possible.
Yeah.
But like goes through a lot of challenges.
Oh my gosh! And how big do these get?
Gosh, I wish I could see the entire list. There was a bunch though. And they basically just give you like you're basically just writing like a tiny little AI. It's cute.
Yeah. With Exapunks, I mean, there's like a long legacy of like bot writing games and robotics, battle bots and that sort of thing. But Exapunks also has this like severe resource constraint thing where you can only like write to 2 different registers.
So funny.
And then so trying to like control a bot to fight another bot with only like 2 registers worth of memory is really difficult.
Boy, that Zach guy sure has a wild definition of what fun is.
Yeah. I love his games. I like pretty
yeah,
much.
they're all
I
great.
bought almost all of them. Yeah, and I have his. I have he published his like creative journal,
Oh, cool.
and I think you can just get it on PDF. But I actually bought the
Nice.
print version, and it's literally kind of like printed out of like a Kinko's or something like that.
It's very on brand though.
Yeah, it's really cool. I wish I had something like that, but I don't. I don't really have anything. Everything is just like type it in the text editor and then throw it away.
Well, time to start putting together your memoirs.
Maybe time to change that up a little bit.
Yeah, it's never too late to start a Kinko's published novel.
All right.
It is too late. There's no more Kinko's.
Can we quickly switch back to the master or main branch just to see the glory of how far we got last time, or even after that?
Yeah, because we have got some stuff going on here. I think.
Yeah, and you went in and like added a bunch of models and stuff like that. And you turned the turrets back on.
Oh, I even modeled some of that myself. I opened up Blender and started shaping some cubes. And
oh, nice. How was that experience?
It's fine. Blender is confusing, and I want to learn more about sculpting.
Yeah.
But like I made the turret a little like domey thing, and let's see if you.
How is there different colors on the tank?
Oh, because I just put a bunch of different used material calls into the OBJ.
Nice.
Yeah. Yeah, and then turrets rotate and fire at you again.
Yeah.
And then they drop these cute little dodecahedron cores.
Yeah, Dean's online. He says we're really getting somewhere. How you doing, Dean?
Yeah, right?
Yeah.
Hey, buddy. Yeah, and then this tree is a new OBJ model that was just a vanilla.
Does hiding not work anymore, or were you just?
Oh, hiding still works, but like they take a shot at you before.
Oh yeah. That's actually not a bad mechanic. I think.
No, I think it's you have to like you can't just hide in one tree usually. Yeah. Like right here. Yeah, probably doesn't work. When I turned the turrets back on, I realized that our bullet range and turret range was in pixels.
Oh, so shit.
Everything had a range of 300, which was much wider than the entire map. So every turret immediately started like aiming at you, nice. Which was cool, actually.
Yeah. Debug draw is not as fast as I would like it to be. Did you just die?
Not as fast? I just died. Yeah. The turrets are good.
Yeah.
Wait, you don't think debug draw is as fast as you like it to be?
It just seems like it slows things down, doesn't it? Does it feel chuggier?
It feels a little chuggier, but only a little.
Yeah. I hope this looks smooth on stream, because it looks smooth coming through Zoom right now. And I know that's an issue when I'm streaming from my computer, or I'm playing the game from my computer, but this looks really nice.
That's great. Yeah, it doesn't make it smoothly through Zoom on yours all the time. So yeah. I'm hopeful that we're getting that on Twitch.
No, it looks super smooth from
that's great
right here.
I mean, these cores are chugging, but
I might have to get a new thing.
I mean, this is what really annoys me, is that this was the cheapest computer I could buy.
Yeah. I kind of want to get a faster computer than what's available, but just because like processing power is just
wait
like
4 months
now at a premium. You know what I mean? Just because we're working on the game and it matters now. It used to never matter to me.
Yeah, it's really weird because I've seen all these games get like the 60 FPS upgrade on PS5. I'm just like, oh, that was probably a lot of work. Like,
yeah,
they needed like all that extra CPU power because like the simulation wasn't running fast enough before. I'm just like, oh, it all makes sense now.
Mm-hmm. Well, cool. Unfortunately, I'm going to have to undo a little bit of your work because
you broke everything.
Well, we're changing formats. So if the GLTF debug branch is like the most advanced version of the code that we've got right now. Okay, so first of all, GLTF. I think you've taken a look at the little like reference poster, right?
Yep. It's totally got that over here. This is cute.
The chief advantage that it has over OBJ is it actually will separate a model into separate meshes so that we can move the meshes relative to each other, which is what we'd like to be able to do with, for example, a turret on a tank or whatever. So not only can you do that, but you can also have multiple models in a scene in the same GLTF file. You can also have multiple scenes in the same file.
Oh, that's cool.
So
that makes sense. So actually, the node, like we could actually stick everything in one file if we wanted to load like everything at once.
yeah. And the format that I'm currently using is JSON, the JSON version of this. There's a binary encoding as well. So it even like sticks like buffer data for
I noticed, yeah, you can stick your whole texture in there as
exactly, and it's just like
base64
encoded, so not super efficient, but
no, it's great. I mean, we're basically taking everything we learned from CSS and just slapping it into something that looks like a model.
Wait, is that what people do now with CSS? They just put images in it?
Yeah, totally. If you want to reduce file size, like you take your 1 kilobyte like caret image for a button, you just set the data URI to the base64 version of that, and then you don't have to download. You have to go through a whole HTTPS request for that extra image. It's great.
Oh, right. Yeah. And then it'll just it'll compress it on transport, right? So it's not that big a deal.
Right. And CSS is already huge. So a couple images don't really add much.
Right. Yeah. So they use the same exact thing. They use the data URI scheme here.
Exactly.
So there is actually a library in JavaScript called glTF-transform that can read this and give you a nice interface. It seemed a little bit heavyweight because it's not only for reading the format, it's also for like modifying it. So if you wanted to like author GLTF files, you could do it through this library.
Yeah, I found this one called Loaders GL, which is just a.
Oh, shoot.
So it has GLTF loader and GLTF writer are like separate objects,
okay.
but
that might be something to look into adopting.
Okay, yeah, we'll see how we do.
Yeah, I kind of wrote it all, or not all of it.
Great.
Like there's actually huge pieces of the format that I didn't even bother implementing, but I kind of walked through it. The reason why I didn't use GLTF transform, I actually started off with that, but then it was like there's a lot of things in GLTF that are optional, and the API doesn't reflect that optionality. So, for example, the get mesh function call is typed. It's written in TypeScript, but it's not strict null checking enabled. So you can call a function whose type annotation says that it won't return null, and it'll return null at runtime. And that's kind of a bummer, especially because we have strict null checking turned on, and also have some things that prevent us from doing things that the type checker says is impossible, which I like. So if we actually try to add like a runtime null check, we'd have to like turn the linter off for that line, which is a little bit annoying.
It is, but it's making our code better. So
yeah.
To deal with that for this other stuff is fine.
Yeah, I think you might be right. So I basically just like kind of spun my own version of this library.
Cool.
The kind of thing to kind of notate in your mind is like there's a bunch of object types in GLTF. There are scenes. There aren't models, but there are nodes. So scenes have nodes, and nodes are basically like either a mesh or a transform or both of those things. So there are meshes. There are also buffers, which the meshes point to, sort of indirectly, because there are things called accessors and buffer views that basically allow you to reuse the same buffer for defining multiple things. Yeah, you're looking at a mesh right now.
I'm looking at the cube, yeah. So
yeah, the cube's real simple. This is a good example. Oh, you can get a really good GLTF plugin. Oh, you've got it. Nice. So yeah, you can kind of rotate that around. Yeah.
This, by the way, is just super sick.
It's really cool. The tank is in there as well if you want to browse that.
Oh, really? Yeah. Let's look at that. That's awesome.
Yeah.
A good little tank.
Yeah. So also, one thing we're gonna.
I love that there's like 4 different ways I can render this. Like, any of them would have been fine, but
the one thing that we're gonna lose a little bit of, although I think we might be able to just hack it back in there, is that you kind of spent some time adding like vertex colors, and
vertex
coloring is just not something that most modern 3D engines do anymore. So there's not great support for that. Although you can define materials inside a GLTF file.
Yeah. And my impression of materials is that it's more for lighting and reflectivity than color. And if we wanted to like, the only reason to use those colors is to add like a shimmer or something that's a tint to an object. So like, we're just abusing the system right now, and we should get textures in here.
Yeah, I think according to GLTF, the material also includes a texture as well. So I think a material is like the combination of lighting parameters, texture, and texture sampler. It's like a bunch of stuff.
I'm not look at the tank GLTF.
Actually, if you do go to the tank GLTF, I do want to just point out one thing.
Oh yeah, totally.
If you open up the hierarchy is what I wanted to point out. If you open up the command palette in VS Code, there should be like an outline view that you can get to, GLTF outline.
Oh, interesting. GLTF.
Focus on outline view. It's kind of midway through the.
Thank you.
Yeah. Okay. So you can kind of break out the hierarchy, and it's going to look a lot like.
It's just the outline view. That's clever.
Yeah. It's going to look a lot like what you see in Blender, and in fact, this is cool. I haven't seen the view that you're looking at, which really kind of like does a nice job of breaking up the entire file. But nodes is interesting in that it basically will show you what the hierarchy of this particular scene is. And so there's a root level node, and I think it's just called tank. And then there's a node under that is called body.
What is like? I see scene 0.
Mm-hmm.
Oh, I see. Okay, so the scene doesn't have 8 nodes. It has a single node that is 8, which is the index here in the tank. Its child is body.
Yeah,
I see what's happening. And then this has 6 children. Okay, cool.
Yeah. So the objects themselves aren't nested. They're not like nested structurally in the JSON file. They're all kind of just like splattered into these top level object arrays, which you can actually see in the outline view right there, right? There's an asset object, or there's an asset array, there's an accessor array, a buffer view array, a buffer array. And so the nodes work the same way. And so if there is a hierarchy, it's defined using what's essentially pointers. And the pointers are just indexes into one of those top level arrays.
Okay. And
so why have a hierarchy? Well, it's basically just so we can have meshes that are positioned relative to each other. And the idea is that we eventually get ourselves like a tree of meshes, and you can actually see that in Blender, right? Like if you open the tank up in Blender, you when you were working with it, you saw it, right? Like,
if I import the GLTF here too, it's actually to maintain the hierarchy instead of the OBJ file, which just sort of splatted everything to the.
Correct. Yeah.
Yeah. Return doesn't import. There we go.
Oh, cool. So you actually even added it to the same scene, which is cool. So if you actually look at, you can kind of break it down, and you're seeing the hierarchy right now. And then the turret itself also has a barrel mesh inside of it,
which is great, because what we want to be able to do is to rotate the turret. Nope, not on that axis though.
Around,
but like
Y,
we want to be able to modify this value.
That's exactly right.
And that seems super reasonable. So I can see, I'm just gonna leave Blender. I guess I saw this in the tank node itself. Oh boy, I've gone too deep. Nodes, tank, there we go. Which has its own rotation and scale that I assume you basically just like keep playing down the stack as you go, right?
Yeah, that's correct. I find it actually interesting that it has this is the way that Blender decided to output this. I would have thought it would just like normalize all of the buffer data so that all of this rotation stuff in the scale was just a no-op. The rotation would be 0 and the scale would be uniform 1 on every axis. I'm surprised because tank here is the root node of the quote-unquote model. One thing that's interesting about this node is it doesn't have a mesh. It has a child, but it has no. It's basically just a placeholder.
Right.
And but it does have a transform. It has that rotation and scale, as you're pointing out. But then if you start to look at some of the other things, like the body, which is the only child, does have a mesh. It points to the 7th mesh in the mesh array, and it also has a bunch of children, right? And then if you start looking at the children all have relative transforms from their parent, which is the body, right?
That's really cool.
Yeah. So that's probably starting to make a little bit of sense, right?
Yeah, it absolutely is.
Yeah.
I'm going to import this again because screwing with Blender is going to continue to be good.
Yeah.
Oops. Oh man, I wish this had like normal Mac key commands, but it kind of doesn't.
It's kind of a mess.
So it's interesting to me too. I think one of the reasons, like these are the values I see. It's not that Blender didn't do it; it just spit out exactly what it saw. So I wonder if we could actually say like, tank, these are your new normals. Like, take all your points from down here and reapply them.
It's a little like flattening an image in Photoshop or something like that. It's like
Basically,
or bouncing down a track and when you're doing audio recording or something like that.
Yeah. So I wonder if that's possible here, and like that seems like kind of a Blender operation to figure out.
Yeah, and it seems like probably a good thing to do. Like the whole subject matter that we're talking about is like your whole asset pipeline workflow, which becomes like its own entire cottage industry or its own like specialization over time when these things scale out.
And the best part is that as we've learned, there's no standard way to do this, and we're just on our own.
So if we go to that, I just want to talk about meshes really quickly. So if we look at any given mesh,
what I want is, there we go.
Yeah.
Yeah, I like that it works exactly the same as the normal tree view.
Yeah.
So we've got our mesh named cube, which is definitely not a cube. This is the body.
I think cube just was, maybe that's just in.
It's probably that whoever, like whenever this was started, it was a cube that was sculpted down. Yeah. So I assume it was you created a cube primitive asset and worked from there.
Yeah, we don't care about the names of anything except the nodes anyways. So if there's names on the mesh, we don't care. Like it's just anonymous when it goes into the game itself. So what you have here is you have a bunch of pointers to what are called accessors. Think of the accessors as just the data. And so your position attributes are in accessor 28. Your normal attributes are in accessor 29. Your texture coordinates are in accessor 30, and your index arrays are in accessor 31.
Okay.
And
so accessor 20 points to buffer view, 28 points to buffer view 28.
Yeah. So the separation between accessor and buffer view, I'm not quite sure yet. But the general idea, if we squish the idea of accessor and buffer view into like the same idea, the idea is that the buffer is just like the raw data, and there may be lots of different things that are interleaved into the same buffer. One example of that is if we actually open the cube, which is a simpler model, you'll see that there's only one buffer in that whole cube.
So we've got our buffer view. We have 3 buffer views, 1 buffer.
1 buffer.
That's interesting.
Okay. And that just means that like if you look at the buffer views, you can see that the byte length and byte offset of this particular file, they're sort of adjoining each other, right?
Yeah. Okay.
Yeah. And so what that actually means is that there's just like different things in that particular buffer. And what a buffer view gives you, and an accessor as well, what both of those things together give you is the ability to kind of look at the same data that's loaded into memory and use it for different things. And so the general principle of that is that maybe you want to only load the buffer once, but it's actually chopped up all the different properties for rendering and that stuff into the same piece of memory. But you don't want to like have to like copy it out n number of times for different uses, right?
Interesting.
There's actually, if you go to the poster, if you go to the web browser, the GLTF poster actually is a really nice example of this. Let's see, if you go down to the 3rd page there, and the bottom half, this whole like kind of diagram, if you could scroll down a little bit, is it possible for you to scroll down? Okay, cool. It basically shows you the idea of what a buffer view is. Like the buffer is just like the whole thing, and the buffer view says, okay, we only care about a particular segment of that.
Gotcha. That makes sense.
And then you can also define strides as well, where maybe the data that you actually care about in a particular buffer view is not contiguous inside the buffer. My current implementation doesn't support this yet. It's funny, actually. There, TC39, which is like the working group that develops the new versions of the browser-based JavaScript API. They're actually thinking about adding capabilities that will support non-contiguous views over the same like uint8 array, for example. When I say non-contiguous, it's saying that like the first element is like every second, third, fourth, and fifth byte, and the second element is every 7th, 8th, 9th, and 10th byte. Something like like one of those kinds of things. But right now, the only way that you can kind of do that without a polyfill is to just copy the data into another array at that point. So I don't support interleaved data right now. I don't support like stuff with stride, which is okay because as far as I can tell, Blender didn't export anything like that yet. So
that's great.
I'm not going to mess with it.
Okay.
Yeah. So this is all just a long-winded way of saying like our actual data for positions, normals, indexes, texture coordinates, it's all baked into this file, and each mesh can kind of have its own, it has a way of addressing into that data, basically.
Nice.
Yeah.
And I'm noticing, well, maybe I'm not quite sure, but based on the accessor, which I think the max and min are actually really interesting. That seems helpful for us to do. I think I saw a OBJ file loader that like calculated these for you, but like I think you can build a hitbox based on that essentially.
Oh, like that is really interesting. Yeah, I didn't actually know what these were for. There's a lot of advanced use cases or advanced considerations that went into the design of this format. So there's a lot about animation. There's a lot about morph targets.
Gosh, I don't know what that means.
I think it has something to do with like facial animation, where you're doing a lot of like subtle blending between like multiple sets of animations or whatever, and so
that makes sense.
There's a lot of things about this format that like we're probably never even going to touch, or at least not for this project. But I implemented it enough to get us to like be able to draw the tank, hopefully. But it's not drawing yet for reasons that I haven't quite figured out yet.
Fair enough. Yeah, we're in the black void at the moment, but
exactly. Yeah.
Let's see what we can do.
Yeah. So first of all, let me show you what we're actually looking at. I basically just like opened up. If you open up client main.ts, that's just our entry point, right? I commented everything out. If you could bump the font size up by like 1 tick.
Yeah, totally. I'm going to go back into the side-by-side mode.
Yeah. Fantastic. I just commented everything out. And if you scroll down, I just instantiated the renderer on line 72.
Oh,
and I just started drawing stuff. The request animation frame stuff is not necessary, although currently it's drawing every frame. We can actually even get rid of that. And all it does is clear the frame buffer, set a world view transform for the entire render. So that's like essentially the camera position, or the inverse of the camera position. And it renders something using the standard method, which is our current method. So that's the cube that you see there. And I did that because I just wanted to have a point of comparison. And then V2 is the new GLTF based.
Oh, okay. So this is actually not our cube, or this is not our GLTF cube.
It's not the GLTF cube. It is the wall.obj that we previously had.
Gotcha. So if we go and take a look at render V2.
Yeah.
Okay, cool. Yeah, different shader.
Different shader. So if you open up V2, the V2 shader, it's nothing surprising. Basically, it's a lot like the standard shader, except that the color is a uniform and not an attribute.
Color is a uniform. Yep. Okay.
Yeah.
So it's kind of how the wire shader worked out, actually.
Yeah, the wire shader is also that, but the wire shader doesn't do lighting, and this one does do lighting.
No normals. Yep. Gotcha.
Yeah.
Cool. That makes sense.
Yeah. So let me just give you a sense of the architecture really quickly. So basically, the draw function is line 281 to line 291. This is what's exposed to external clients, basically. Is like you basically say, what model do you want? And the name of that is actually just the name of the root node in the GLTF file that you imported. So if the root node, so this is actually tool dependent, right? It's not the way that we defined it for OBJ files is that it's actually specified in our game source code. But here it's just like whatever
It's
the
actually
root node is
tank
there.
or
Yeah.
cube.
Yeah.
Okay.
And the renderer actually keeps a list of all the top level nodes that it loads.
Great.
Yeah. So that's the way it looks it up there. In fact, you can see it looking it up in the renderer, the render v2 function there. Inside this anonymous function, you can see on line 286, it just looks up the root node based on that model name.
Gotcha. And did you have to? These got loaded. Yep, totally.
Loaded. Yeah.
Okay. So let's see. We've loaded a GLTF specifically here, which is the cube.
Yeah. And the GLTF is actually a whole scene. And as you can see, what I did here, we don't have to, we can sort of slice and dice this however many different ways that we want. But what this does is it just like takes the entire JSON blob, iterates over every scene, iterates over every top level node in the scene, and loads all of those. Yep. And then it essentially just walks the whole hierarchy and follows all of these like numeric pointers across the entire GLTF file and loads buffers as it needs, so on and so forth.
Wild. Okay.
Yeah. And then like if you go to the draw function again, render v2, once it's got the node on line 290, it calls render node. And these the parameters that you pass in are just like stuff that the shader cares about. The shader cares about a model to world matrix uniform. It cares about a color uniform. The projection matrix is already set. And the render node basically says, okay, I'm going to take whatever local transform is on this current node and then multiply it by the parent transform that's getting passed into me. And in this case, it's just like at the top level, it's the model to world thing. It's basically the position of the entity, right?
Right. So on the, I mean, this is specifically the tank where we will rotate or scale. Yep.
Yeah. If I have a local transform, I'm going to also add that into the mix and overwrite it. That's all of line 301. If I have a mesh, I'm going to render that mesh. And then I'm going to go iterate over all of my children and just call render node again, right?
Nice. So maybe one of the things that I don't see here yet, which makes total sense, is that we don't have like a connection to the entity for like how we want to rotate something.
Yeah. So there's no way to parameterize that yet. Although I have some thoughts about that, about how we might want to do it. We can talk about that later. And I just wanted to give you an idea of like what's changed. Now we have this kind of recursive tree walking structure because a model now is a family of meshes. In fact, it's a tree of meshes. And you can see how the transforms stack. Line 301 is where the magic happens, right? And that's how we can kind of get transforms to kind of like hierarchically stack on top of each other.
Yeah, that's really clever, and that's going to be really, really, really nice for texturing and coloring and all that good stuff.
Yeah. Now, I anticipate that there's going to be like probably some kind of arbitrary key value mapping that allows us to modify attributes. So we'd add a parameter just like you were proposing that says, okay, I actually want to do some like additional modification of a particular node.
I was thinking maybe there's like sort of maybe a global state mapping of that where actually our systems are writing into that.
Yeah.
And like the input system and maybe some wheel spinner system is just incrementing a counter and it sort of maps to the same way. It maps the tree the same way that the GLTF file does. So we can drill down into that.
Yeah. One thing that I haven't quite figured out yet is that line 301 probably scaled over 60 frames a second, scaled over however many entities that we have and however many nodes they each have might get expensive. And so this is maybe something that we'll think about caching. But for now, it's just kind of brute force.
That's fair. Yeah, I could easily see this being baked in.
The original OpenGL API actually had a thing that helped you do this. Basically, they had this global stack of matrices. So if you look at like old OpenGL code, you'll see push matrix, pop matrix, which basically
that's clever.
And it's all like modifying this global stack of matrices to basically simulate this exact thing. Like a stack is a data structure that allows you to do depth first traversal of a data structure, right? And so basically, this is a depth first traversal of a node hierarchy. So it kind of like maps
that's really
pretty
interesting.
nicely, yeah. And I think OpenGL in the olden days, they had some form of matrix caching built in, but I think it became too inflexible, so they decided to just like let you do it. Basically.
Now, could we stick a array of matrices in a uniform and pass that to the graphics card? Because I do think it'll be faster than us.
You can. I think the question is like how. Yeah, you can definitely do that. I think is the simple answer. When you start to deal with like variable length stacks of matrices that need to compose with each other, that's where my knowledge kind of runs out about shaders. Is that like commonly done? Like I actually have not 5 matrices, because if you look at our shaders right now, the number of matrices is fixed, right? There's like a fixed number of matrices when we do composition.
Yeah.
Now you can do loops. You can do for loops in. This is a lot like C. I mean, the GPU is ultimately just a kind of like specialized but Turing complete, CPU that you can write loops and do conditionals and stuff in. So if we wanted to,
I guess I was thinking like caching sounds hard, but actually, if we could just, since we're setting a uniform on every mesh anyway, why not just hand it off to the thing that has a matrix multiplying chip in it?
Yes, for sure. The savings that we get from doing it inside the CPU the way it is right now is that we do get a little bit of pre-computation for free, right? So, because like when you arrive at like a leaf node, let's say a leaf node has 100 other siblings, right? It's like a centipede model or something like that with like 100 legs. You don't have to remultiply all of the ancestor matrices, right? Because they've all been already like multiplied together before for you.
Yeah, exactly.
Yeah.
So we'll see.
Yeah, cool. So
okay,
the conundrum that we're looking at right now, it's like nothing's rendering right now.
And we're sure, right? Like
yeah. If you get rid of that and let it compile, it's gonna take a little while for the
Okay. Yeah, I just want to be sure they weren't like rendering on top of each other.
Oh yeah, that's a great thing to think about. Yeah. Unfortunately, there's no great way of debugging shaders right now. Yeah, a lot of people will just like say you can debug a fragment shader by like writing arbitrary colors to the pixels and just make sure that you're getting the values that you want. So there's probably a lot of shader programmers now can like see numbers in colors, I bet, right? So that they look at a particular color, they're like, oh, that's between 1 million and 10 million or something like that.
I mean, I guess one way we could debug it is put our V2 shader on our old renderer. We could confirm that it still works, but like it's almost exactly the same code. I'd be surprised if it didn't.
Yeah, I did a lot of like line by line comparison just to make sure. But one thing, if you do look in Safari, if you click on warnings in the logs, I think we should see a warning.
I don't. Do you want me to try like Chrome?
Yeah, that'll work too. You can just go to localhost 3000. Right now, it's not talking to the server anymore. So.
Oh, delightful. There we go.
Yeah. So that warning is basically saying, if you comment out the render v2, that warning will go away. Yeah.
That makes sense. Cool. Yep.
God, that your compile so fast. It's nice.
Is it? It feels so slow. Okay. Attempt to access out of range vertices and attribute 0.
Yeah.
So let's see. So our attributes.
If you go to draw render mesh,
To say attribute 0, I'm going to assume is position.
I think it's just the first attribute.
We can certainly. These are just integer indexes, right?
Yes.
And then so my next assumption is that the data we're feeding in here is actually an empty array.
It's
Yeah,
funny
0,
because
1.
I actually had some debugging that demonstrated. Oh, actually, you can actually set a breakpoint if you scroll down. Set a breakpoint on the actual draw elements call, which is a little bit below this.
Oh man, I'm not running this through debug mode. Crud.
Oh, that's okay. That's okay.
Yeah.
We can just above the draw call, we can just console or anywhere basically. We can just like console log a bunch of stuff.
Okay. Yeah. I should. This is draw elements. Yeah, I should really get that set up because that'd be super useful.
Yeah. Console log position buff, then normal buff, then index buff, and we may need to JSON.stringify them, but we'll see what happens.
Let's see what we get. Pause buff.
Position. Oh, pause buff. Yeah, sorry.
That's okay. Alrighty.
Oh,
yep.
This is brilliant. Wait, console log in the browser is really good.
It's really good in the browser. Yeah. In the terminal, it just does some strange nonsense.
You get like object or something like that, right?
Yeah. So 24 points, 24 normals, and 36 indices, which makes total sense for our cases.
This looks correct to me. This is about as far as I got this afternoon before we hopped on, or before I ate lunch and then hopped on stream. So this is basically the kind of debugging that I would like to do. Just to refresh your memory really quick, we're actually using the draw elements mode of OpenGL and not draw arrays. And the distinction there is that we want to save on memory. So basically this allows us to save on repeated vertices that have the same values. So the face of a cube is composed of 2 triangles, 3 vertices each, which means that 2 of those vertices are shared, right? The 2 vertices that are on the diagonal. And you can either repeat those 2 vertices in your position data and your normal data and call draw arrays, or you can not repeat them and then use a separate array, which is the index buffer, that tells you what the vertices actually are, and the index buffer points into the actual data, right?
So I see us binding the buffer here. We load the data. Okay, but I think buffer get buffer subdata is what I haven't seen before.
So I just found out about this. I basically when we loaded the GLTF node, we created OpenGL buffers. The way that I did this, and maybe this may be the bug, but the way that I did this is that instead of binding them to a VAO and like keeping the VAO around, I wrote the buffer data and then didn't attach them to a VAO. So I'm right now creating a VAO dynamically and then destroying it, which I think we should maybe try to not do. Unfortunately, I think WebGL buffers are they're not meaningful objects in JavaScript. I think they're just like...
nothing in there. Okay.
There's some internal state that points at an internal thing, but you basically just, if you pass it into something like get buffer subdata, then it'll basically copy the stuff out of it'll copy data out of that buffer object and then let you console log it like the way that we're doing it right now.
I also noticed I don't actually see. I do see 23 here. Okay, so this doesn't look like it's going out of bounds on either of these.
So where it gets confused, where it can possibly be going, sideways, is that I screwed up either the vertex attribute pointer call, or I screwed up the parameterization of the draw elements call. Internally, OpenGL doesn't know what this data is. It's just like a raw chunk of memory. And you have to tell it like, oh, it's floats, and there's n number of them, right? And so I think that's potentially what I might have screwed up here, is that it could be that when I call draw elements, it's looking at the indices and maybe interpreting 4 bytes rather than 2 bytes as the index. And so therefore we're getting like some giant number So it's trying to like, instead of looking at like array element 1, it's looking at actually array element 243, right? Something like that.
Yep. Okay, so I gotcha.
Yeah.
So where in our... Okay, so wait, so where is this mesh object stored? We've already parsed the GLTF file here.
We have parsed the GLTF file. And if we actually take a look at the values, like it's a little bit confusing where these get generated, but we can actually just look at the values that they're assigned. Oh yeah, we can't do a breakpoint. We can console log them at least.
Okay.
Yeah.
Yeah, somewhere.
Yeah, everything is in. If you go to make node line 527, you can follow the whole hierarchy of code that like loads this data.
Gotcha. Okay.
A lot of this is boilerplate, just because like this format's a little bit too flexible in the sense that it's allowing a lot of things to be undefined. So a lot of this code, it ends up looking like Go code. It's just like, is this here? And if it's not, then throw an exception.
Well, maybe before I do anything else, let me just log the whole.
Yeah.
See what it thinks we've loaded.
And this will be interesting because it's hierarchical, right? You can basically, or actually the mesh is not hierarchical because it's just only one thing and should be relatively simplistic.
God, what are these GL types though? I mean, I assume, I guess I feel pretty safe saying that like these are floats.
In fact, I actually have it written down. If you go to glTF index.ts or types.ts, I'm sorry, glTF types. And let's scroll. This is...
There you go.
Yeah.
Unsigned short. Should it be unsigned? Shouldn't it be signed? Oh no, not this. This can be unsigned. Yep.
Yeah. So the index buffer should be unsigned shorts, which are uint 16s, which is a 2-byte unsigned integer. And there's 36 of them, which actually makes sense because there are, again, 2 triangles per face, which means that there are 6 vertices on each face and 6 faces on a cube. So 6 times 6 is 36, right? So that checks out, I think.
Yep.
And the normals.
And also these values were just in here correctly. So we haven't done anything weird.
Yeah, right. Yes. So you're looking at the
cube model.
Yeah, totally.
And it looks like, I mean, I feel confident that this buffer has been parsed.
Because it looks pretty good, right? Those positions.
It looks pretty correct.
Look
yeah.
Correct. And then the normals there will also look relatively correct. The reason why there are 24 values in the both position and normals is that there are actually 4 vertices per face that have unique values. There are 6 for the purposes of drawing triangles, but 4 that actually have unique values. And there are 6 of those on the cube. So 4 times 6 is 24.
Yeah, exactly. And it's like, it's even fewer, except we have to do the normals differently for like corners.
Yeah.
Because otherwise, like you could.
Although, hold on. Here's what's interesting. I think I know what the issue is here.
Okay.
There are 24. There are 4 vertices per face. And then there are 24 vertices per cube. But there should be 3 times 24, 72 actual floating point values.
Or so these have been lost somewhere. Yeah.
Yeah.
That makes sense. Here, wait. I think. Where's my? Oh.
So that's why. That's why it's indexing out of. That's why we're getting that warning saying that we're jumping outside of the bounds of a buffer. Because sorry. Go ahead.
Well, just to bring it back to our previous cube, there are 24 total values for our points here, and 36 values for the faces because each face is 3. Or sorry, 36 values for the faces that reuse some of these 24 X, Y, or Z. So these numbers look really familiar to me because we've basically done the exact same thing before.
There are 24 unique values, but the problem is that because the normals change per vertex, you need to repeat some of the positions twice.
Repeat some of the positions twice.
So if you take any given corner of a cube, it actually needs to have that same position 3 times in the position array. Because
shouldn't the normals array just be longer?
Well, we can't. The position array and the normal array have to be the same length. You can't give 2 different index. You can't do 2 different index buffers for 2 different attributes. It has to be the same index buffer for both attributes.
Oh, funny. Okay, so right, so this is actually like this is the pre-baking that into the data version. Because actually in our OBJ loader, we did this. Where when we got a vertex, we pushed things 3 times at some point. Yeah, here you go.
Yeah. And so our OBJ loader is actually even more verbose than the GLTF version, because the GLTF version at least will save on vertices where both the position and normal values are exactly the same for a particular vertex. Which is basically for 2 vertices per face are repeated because they have the same normal value and the same position value. But to go back to what I was saying before, we should have 72 values for the positions and 72 values for the normals. And the reason why we're getting an out of bounds or out of range warning is that what the draw elements call is going to do is it's going to take that index, let's say index 14, and it's going to multiply that by 3, because we're not choosing a floating. We're not choosing a floating point number. We're choosing a vertex, and the size of each vertex is 3 floats, right?
Size of each vertex is 3 floats.
Yeah, because the index buffer there, that uint16 array, is basically saying it's picking vertices, right?
So if I was to look at these in groups of 3, I see the same vertex 3 times, which I expect because everything should be 3 times on a corner.
Right.
And actually, if I do that, I actually only see...
Exactly. Yeah.
I saw something which might have been doing it. This is actually hard coded. And so is this.
So that's all debugging code, right? And
it is okay.
And so if you actually make that number higher, like if you just make it to 25 or 36, it'll crash because the buffer isn't actually big enough. So this is a loading problem. I think that's essentially the conclusion that.
Wait, sorry, were you looking for 96 values? What is this?
I don't know.
Oh, this is fascinating. I've never seen this debugging chunk. Never mind. I think it's actually reading it as different types of.
The array buffer. The array buffer is essentially how big the bytes is.
Yeah.
And those are different views over the same.
Never mind.
Bytes. Yeah.
Okay, so well then, taking that back a step, we don't actually know if we don't have enough values here because our debug code.
Yeah.
Is just shorting stuff.
Yeah, so try try multiplying by 3, and I think what's going to happen is it's going to crash because it can't. The get buffer subdata call can't read enough data out of the buffer because it's not loaded in.
Because we didn't multiply it on the input either.
Yes, so I think that's exactly the problem.
Okay.
Yeah, see that new warning that's there.
Oh, okay, great. So. Okay, if we were to, what was it, load?
It's inside model. The GLTF index.ts. I kept most of the GLTF specific code out of the renderer class because I figured we didn't really care.
I think that's, yeah.
So I think this is probably, what is this function called? It's called like apply accessor or something like that.
Make a renderer buffer?
Okay. Yeah, so it's at some place in these 2 functions. This function that we're in right now, I think, is called apply accessor. Oh, make mesh.
Make mesh.
And then if we go to make render buffer, if we go into that,
yeah. Well, it's just interesting. So we're getting our indices, and our indices we think are good. But it's,
I think our indices are good because it's 24 long, or it's 36 long.
Mm-hmm. So really, is it that we've actually? Is it actually that we're reading too few elements out of the buffer itself here?
That's exactly right. We forgot to multiply something by the degree of an item. So it's a little bit confusing because the vocabulary is, we actually have like multiple concepts of what is inside the buffer. Your buffer can have data per vertex, or it can have a bunch of floats, or it can have a bunch of bytes. And you can use that same language to talk about the same exact chunk of memory, right? Are you talking about array of vertices? Are you talking about array of floats? Or are you talking about array of bytes? And
interesting.
I think what's happened is we forgot to multiply somewhere by what's known as the attribute or element size, or the degree of the element. Right.
So I'm just gonna look at this top to bottom. This is, I think this one is position, normal, and I don't know. Shit, what's our fourth one? Oh, textures. Yeah, we're not worried about texture coordinates.
Anytime you say vec2, that's going to be like a texture coordinate, right? Because those are two-dimensional.
Okay. So the third one's less important.
Yeah.
But so byte length seem
288 bytes divided by 24 elements divided by 3.
I was gonna say is 3 4-byte floats, which
yes, right. So we're missing a multiply by 3 somewhere. I think that's basically what the issue is.
Yeah. Is it because it's a vec3?
Yeah.
That's why. Okay.
Yeah.
So we need, when we do our accessors, we need to look at the type.
Yeah. And we've got all that information. I think I just somehow forgot to add that in there somewhere. So it's probably in make render buffer, right? Because make render buffer is actually the input is pretty nice. You get the whole document. You get the whole friggin' GLTF
Okay, that document is the whole thing. That's great.
And the accessor ID is just a pointer into the accessors array. And then there is a point where I will call apply accessor.
Okay.
And that's basically saying, okay, I've got the buffer. I've got like the raw bytes of the buffer. But I want to actually take both the accessor parameters and the buffer view parameters and read data out of that buffer. Because you remember with the cube, it was just one single thing, right?
So accessor type degree looks like the magic, which does get called in. Oh, so I see. This is written off as element size, but it's not actually element size. It is number of elements, right?
That is the element size. Basically, the element, the way the word element is being used here is it's basically what type describes. So you see that type parameter, like vec3?
Yeah. I mean, this is what's missing though, right? Like, we're actually instantiating arrays that are element size too short.
I think it's actually the degree. So it's accessor type degree.
Accessor type.
So we can store that in the degree is basically saying that there are 3 floats there are like 3 floats in a
multiplied. Yeah. Yeah. Great. Okay. Cause right. That was too many. That was the full bytes array.
Yeah.
This, I would expect to fill up this array in a second. There you go.
Oh, and it's
brilliant. We did it.
Well,
yeah, that's great.
Nicely done.
Now, I guess, is this thing facing the camera head on? And
I don't think we have any offset. So if we go to the client main, and we just fudge its offset a little bit.
Okay, it's rendering at 0,
it's adding 110. I wonder if you try setting that to 220.
Let's do let's match the other one and just be on the other side.
-6 is actually the worldview transform. So
oh shit. Yep.
Yeah.
Thank you. Oh, this is 110. Okay. It moved, but it sure.
Oh, that's color. 91 is color.
Sorry, what am I looking for?
Yeah. You're looking for line 90. That vec3 is the translation.
Oh.
I'm not convinced it's doing anything.
Yeah, same. Still render, or still, no, not still building. So we do like, yeah, it's strange. There we go.
Oh, there we go. Okay.
I think actually maybe it was in the camera. And we were looking at the back face of it.
Interesting.
Yeah. Does that sound right? That's
yeah. I can't remember if I think I got rid of the comment out of the backface culling, but I'm not 100% sure.
Well, backface culling, when you're in an object, you still see the inside of the cube, right?
You shouldn't. No.
Oh, okay.
And we could try that out by flying the camera into the cube and seeing what happens. But yeah, so it looks like we
Can't
fixed
do that
it.
yet. That's great. Well, what if I were to do this?
Yeah, if you check the render function, I think I might have some debug code that might screw this up.
Unknown model.
Oh, we need to load the model. If you just scroll up, just copy that line to tank.
And while this is happening, I'm just gonna take out some console logs because.
Oh, there's the tank.
Heck yeah!
Yeah.
All right. Well, that looks like GLTF to me.
It does.
Don't need any of that. That's for sure. Cool. That seems great.
Yep. Okay. Well, this is fantastic. I actually think this might be ready to merge into master.
Yeah.
But
let's
if we can actually go through and delete some code.
I want the game to work again. Yeah.
Yeah. Well, basically, let's go ahead and we might want to do some git commands to do this. So, because client main should just be client main of the GLTF renderer branch.
I just say I'm just going to grab it off of Let's just get it out of GitHub and go from there.
Or I'll tell you what. Why don't we just go to the GLTF renderer branch? Because I know exactly the only change that we've made.
Oh, is it just that? Okay.
We can.
It was just to the, not here, but the GLTF index.
Yeah.
What are you gonna say? Sorry, I was just gonna rewrite the code.
Oh no, that's totally fine. What I was gonna suggest we also do is, it's funny. I feel like I had this code, and for some reason it wasn't working. But maybe I was just using the wrong number. It's very easy to get all these different numbers confused.
Yeah, totally. Yeah, because I was confused by degree, element size, and type size. So
yeah. Okay, so what should happen when this fires up again is it should actually run the game, because we're on that branch now, and we've. Whoa, what is going on here? Oh, you know what? I think maybe I haven't. Oh yeah. This is working, because that tank is not your original tank, right?
It's not my tank. So let's figure out how we can confirm that.
Yeah, let's just if we go to the client sim code, and then we go to get renderables 3D v2, the one below this. Let's change the color down there on line 497. And
it really is just it's funny.
Yeah. So this will be some kind of darker magenta, darker purple. Right?
I do expect that to change his tank.
Yep. Oh, nice.
Sick. Okay.
Well,
cool.
It is working.
Wait a minute. What is this? How does this work? Okay, we're just handing it a second renderable and telling it to go to town.
Yep, exactly. I just made a parallel universe next to our old renderer.
That's great.
And then if you look at the player creation function, so player.ts or player index.ts, I forget which of those two we're using. Line 29 is we're no longer setting the renderable property, we're setting the renderable v2 property.
Okay. That's great.
Cool. So this can go into master, I would say.
Let's do it.
And I hopefully won't collide with anything that you've already done with OBJ stuff, except that we're going to have to implement some of these things.
Yeah, I mean, we can rebase master. I think it's commit fix array buffer size for GL.
Yep. They could have called that format GTFO and just like made up like it'll be like GL, because GLTF and GTF are the same, like because GL, it could be just part of the letter G, and then O could be
object.
Yeah, exactly.
Yeah.
GL
what
transform
is it?
object.
It's GL transport.
Transport
it's right now
format.
It's transportation format. Yeah. Transmission format.
Transmission format. Transmission format object.
Yeah, missed opportunity. I mean, that's, hey, let's just restart the server. That's why we get paid the big bucks, because
yeah, exactly.
we're good at naming things. All right, rebuilding.
Uh-oh.
It is strange that there is no tank.
Where are we right now, source code wise?
We are on master. Oh, you know what? And I merged GLTF renderer.
Okay.
And it's weird because GLTF renderer, I merged master into that, and it was fine.
You rebase master of that, and then you merged the other branch.
And then the merge, yeah.
Okay, yeah. So there's no merge commit. It's just fast forward.
Well,
okay, let's just walk through it.
yeah. I feel like we're so close. Render 3D, and then where's our get renderables? Let's see, we've got our V2 shader. It's hanging out here. We've got our renderer V2, and then in client sim. Oh, you know what? I don't think got changed. Oh no, this is here.
Yeah, that's loading. Is there any warnings or anything in the Chrome console?
No. That's surprising.
What happens if you hit the little what do you call the double greater than sign? The little
the double greater than sign?
In the dev tools, there's that little like what do you call it? There's no warnings thing.
Chevron, yeah.
Whoa. Okay. The warnings are useful. I didn't know to look for them.
That's fascinating.
Yeah, we have some long frames. I don't know why.
So it's like, well, it's because our frame is also our it's doing our simulation too, right? So we're getting the occasional like long timer.
Yeah, it might be GC potentially.
As I say, this is basically like a dropped frame for the CPU hanging on us. Yeah.
Yeah. I mean, 16 milliseconds is like
be
multiple drop frames. It's crazy. It's really bad.
Yeah. But this also seems to be like when I'm fucking with stuff too.
Okay.
Like, I think the active
it doesn't actually have
closing
it doesn't have the CPU or something like that. Yeah.
Yeah, there's a whole lot of reasons that or if I like go over here, who knows?
Yeah.
It's not like doing it a ton though, which is good.
Okay. What if we go to player index? We'll start there and see if it's selecting the right model. Okay, it's V2. Let's go to GLTF index and see if your fix is there. Maybe it didn't get added correctly. Oh,
There?
it's there.
Got that, yeah. Was there any other fix? That was it, right?
You know what? There might have been another fix on the debug branch. Let's check it out in GitHub.
Okay. Yeah, now we can just do a compare on this.
Yeah, exactly.
Oh, let me push this. Do you not? It's there. We go. Okay. Nope, you're just loading some other stuff.
This is all client main stuff, right?
Got the cube, which
is for debugging. That is also for debugging. That all looks like debugging code to me. How unusual.
I want to just like our render v2 here is doing the right thing, right? It does look right.
Yeah.
And I guess if I check out GLTF debug, actually, you know what? Wait, I'm gonna do a yarn clean before we go any further down this path.
Okay.
Just cause you never know.
I still don't know why our projection looks fish-eyed. Do you know what I mean?
It really does, though, doesn't it?
Yeah.
Yeah, I would like to figure that out. I think it's tough too because like we end up with okay, great, we're fine. Yarn is not
unbelievable. Parcel.
It really looks fisheye, and it's tough because like I feel like I've got it sort of set for this, but when you do it on a truly weird scale, you end up. I feel like I don't know.
Well, what is the FOV again? 75.
75, yeah, and maybe this just isn't 75. Like it looks weird at this scale.
Yeah, I don't know.
Because I quite like it at like around here and around here.
Yeah, that's pretty good.
Yeah, which oops. It's reloading broken?
What happens is the server crashed. And the server, unlike the browser, have you noticed in the browser if there's a thrown exception, it just keeps chugging?
Yeah, it's great.
Node.js, thankfully, just crashes the whole interpreter. It crashes the whole runtime.
A crash for software is a very Ryan Smithism, and I did appreciate it.
Yeah.
Yeah, dude, this looks great.
It's not everybody's philosophy. At work, we do a lot of PHP, and PHP is definitely just like try to keep running as much as you can until you subtly corrupt your data.
That is the PHP way.
Yeah.
But like, there are worse ways.
Yeah. Should we animate that freaking turret?
I mean, that's what we did all this work for. So
yeah,
darn tootin' we should. Yeah. So I guess we have a player input system, and that feels like a place to maybe start because we need this data.
Yeah.
And we need our handle attack input, which is our client mouse pause. I guess we're actually feeding this into the message buffer too. Like there is at every frame.
Yeah.
A target pause.
I think we actually used to deal with this. And I don't remember if we dealt with this in player input or if we dealt with it in the attack system. If we can like go back to our 2D code in GitHub, maybe.
This? Nope.
No, that's debug draw.
Yeah, there's a bunch of new stuff in here. Yeah,
it might have been
in
the attack system. I think. I bet if you look at the history of that file, you'll see like. Do you know what the greatest button in GitHub is?
T.
If you click blame on the code view, not the blame button per se. See that little that one right there, view blame prior to this change? That's the greatest button ever.
How long has that been there?
For at least a year and a half.
Oh
Yeah,
man,
yeah, you can go back in time. It's so good.
I feel really, really dumb. That's so useful. Also,
Yeah.
my work doesn't use GitHub, so it'll only be good for this project. But
Are
it's
you on
so good.
Bitbucket?
We're on the GitLab. We have an enterprise GitLab instance that we run ourselves.
Is it good?
It's okay. It's
Okay.
overstuffed.
Okay.
And like they're like 2 years behind GitHub on features and performance, but are trying to catch up as fast as possible. So they just wrote a bunch of slow features.
Oh.
Like there's a projects view, just like I don't know, whatever it is in GitHub that's supposed to be Trello, but it's like a bunch of asynchronous calls that aren't cached that really should be.
That's so
I
funny. That
know.
seems like the least useful feature to clone is the project management stuff.
Yeah, but they want that sweet Jira money, I guess.
Oh. That's maybe supposedly the soft underbelly is that's where they can attack is like, can we just get more of the Jira money?
Yeah.
Then yeah. Okay.
We're trying to put everything through GitLab because since we're paying for the thing and it has these features, we're like, well, what if we just use them all? And
Is it like a
turns out,
HIPAA thing that you can't use GitHub Cloud?
I think we are. I think it's like significantly easier to do HIPAA hosting our own code version control.
Oh, yes.
Yeah,
Okay. Yeah.
it's
Yeah.
like
Or
not sending our code somewhere else means that like if you accidentally paste someone's credentials or someone's like personal information into it, you don't have to call GitHub or like issue a notice to someone, which is handy.
Got it. Okay, that makes a ton of sense. I think, yeah, because like Slack has been interested in getting FedRAMP certified, and that's like a lot of this kind of consideration is like where are your builds happening, where's your CI, all that stuff.
Yeah, it's annoying.
Yeah.
At the end of the day, though, like it's just work, and like the tools work fine.
Right. So we want to look at an old version of this file that was like predates our 3D system.
Yeah,
that's
which
gonna have.
I sure bet it was here. Yeah.
Yeah.
So what I want is.
You can just do view file, I think, in that little ellipsis.
Yeah, I just need to find. I want like when I'm on the history of file and I go here. Oh, is this the thing?
That's copy the commit.
Damn it! Is this view file? Nope.
No.
I want one of these buttons to be view the attack system file for this commit because that's always what I'm trying to do.
Yeah, it's in the drop down here, but I know exactly what you mean.
It's just like I click on it and I'm like, wait, this is no longer attack.ts.
Right.
So let's see. It could be here. Mouse orientation. My guess actually is that it was in the player renderable, which I don't think this file exists anymore. But
it's not reading the shooter system.
That we might still have. We do. And it's still updated, right? Yeah.
Oh, of course. Right. Attack is for doing the damage. Shooter is for actually determining the shot.
Doing the shooting.
Yeah.
That's great. So the shooter has an orientation that is updated based on the mouse, and that's there.
So how to actually do this? The shooter system maybe should just update the renderable. Maybe we can make the renderable more complicated than it is right now because it's just a string currently.
It's just a string.
And what it should probably be is the model name and a set of animation parameters. Something like that.
Okay. So let's see. We probably need to dig into the entity manager. Do we have a renderable v2? We do.
Yeah, but it's going to have to become a component table of an object.
So this is like a GLTF. Nope. GLTF.
I think it's just called a renderable now. GLTF is actually kind of independent of this. It's just the input format.
Okay.
Yeah. Hey, how's it going? Just okay at games.
Oh, who's that? Hello.
They have a kind of cool king, like a crown icon next to them in chat. I don't know what that means. Does that mean you're the king of this chat?
Have they taken over? I mean, that's fine. No gods, no masters, but like you can be king for the day.
Yeah.
But
not my president, but certainly my king.
I mean, like I don't believe they're just okay at games. They're probably pretty good at games.
Yeah, I think just okay is the ultimate. So what do you call? It's not a humble brag per se. When somebody demurs when receiving a compliment, it's like, oh, you know what? It was a team effort. It was a team effort.
I think maybe that's just being humble.
Okay.
Not the humble brag at all.
Well, okay. Well, what do you call it when somebody somebody went to Harvard, but they're like, oh yeah, I went to school in Boston. Do you know what I'm talking about?
Yeah.
Yeah.
I would say still humble. Yeah.
Oh, I see. It's yes, just okay at games is a colleague of mine. How's it going?
Nice.
It's really good to see you. Happy New Year.
Happy New Year.
And I'm flattered that you would spend your New Year's Eve afternoon on Twitch.
I'm glad we're doing this a little early because people can tie one on afterwards without having to watch us.
Exactly. Yeah. I'm gonna go to bed at like 9 p.m. tonight. It's not gonna be an exciting New Year's Eve for me, I think.
Man, seriously, right?
Yeah.
It's weird. How's Nier Automata, by the way?
Nier Automata. Let's see. I am like 20% of the way through the second playthrough.
I'm gonna say that's exactly where I fell off the game, basically.
Well, you're playing 9S, right?
Yeah. Doing all the same stuff.
And you're a lot weaker, so you have to like hack everything.
Mm-hmm. Which is like a really strange mini game that just shows up in round 2.
And you have to do it a lot. You have like anytime you're like fighting a difficult enemy, you kind of just have to do it all the time.
Yep.
Oh, Just Okay Games says they're keeping their 9-year-old up to stay up for presumably the descent of the. Are they doing the Apple thing in Times Square this year at all? Like it would seem irresponsible to encourage a crowd, right?
Times Square is closed, I think.
Okay,
but they could drop a lot of stuff out there.
Yeah, but it's still a good occasion to keep a small child up till midnight or past that. Yeah, got to sing that old lang syne. So Nier Automata. Yeah, it's just. I wish the storyline and the characters were more likable than they are, because it's just like I feel like the pacing and the execution is so clunky that any kind of like import that they're trying to get across, I think they trip over themselves a bit. Because like what they decided to like actually have voiceover VO for, and what they decided to just like put in like text you have to read is like super arbitrary.
It's weird, right?
Yeah.
I feel that way about Yakuza games too.
Yeah. I mean, Yakuza has that problem as well, and that's like a resourcing problem, right? You just can't do the VO for everything.
Totally.
But Yakuza games make up for it for just actually being really well written, whereas I'm not convinced that Nier Automata actually is.
Yeah, you might be right.
Okay.
No, I'm just curious because that you're at the exact point where I sort of fell off the game because I was like, I don't really want to play this part of the game again.
Yeah.
But I know there's a chunk coming up where like 9S and 2B get separated, and like you'll totally see the other half of the story, which is probably maybe interesting.
Yeah, and then you get to play 2A at some point, I'm told.
Yep.
Which I haven't got to, and did I just spoil? I think we're spoiling it for a lot of people.
You're spoiling for someone, yeah. Well, I mean, it's okay.
Yeah.
It is like a 4-year-old game, so I don't know. Whatever.
Yeah, it's true.
Am I any commas and interfaces? All right. Well, anyway, while we've been spoiling other games, here's a stab at a renderable interface, which is a name, which is our model name, and then actually I'm going to call this our mesh name.
Yeah.
Or actually, that really could be the key too. So maybe that's unnecessary.
Yeah. I'm almost thinking one way to start this off in a really basic way.
Mm-hmm.
Well, hey, like the most primitive thing that we could do is we could have a map between mesh name. I think it is a map with a key as a string. We need to decide like exactly what that looks like, and then the modifier could literally just be a transform.
Yep. Okay, which is just a 3 matrix.
It's a 4 matrix, but the question I have in my head is, do we want to decompose that into rotation, translation, and scale, or is it enough to... It might be fine just to start with Mat4 and see if we need to do something a little bit higher level.
Because we can fit all those into that, right?
Yes. Tank.turret is a really good idea. I was thinking tank/turret, but I think we're thinking along the same lines here.
Yeah, doing a key path essentially.
Yes, it is a node path. That is the key.
Node path. There you go. That's
do you have any objection using maps rather than? Oh, you know what? Plain old data is fine. Plain old data is fine. I'm
mostly just for plain old data. Yeah.
Yeah, easier to clone, I guess.
Easier to clone, easier to write out. I mean, Mat4 is. I guess I like that our GLTF matrix is almost plain data. Not quite though.
Yeah.
All right, let's bring in this renderable. What are you grumpy about? No, oh my gosh, come on.
How many renderable classes do we have? I think it's starting to get to be a disaster.
Oh man, I was hoping. I thought we were down to none. Oh no, never mind.
Oh, there's the 2D renderables. What else is there?
2D and 3D.
There's a renderable 3D. Oh Christ.
Okay, well, how about this is entity model,
or just call it model. I mean, I guess we have a bunch of models. We have a model inside the renderer.
As I say, I guess I wanted to distinguish like the model, which is the we have one tank model, but there are like 3.
Entity model's fine. Entity model's great.
Yeah,
because it is in the entity manager.
In the entity manager, and it's feels like it's tied 1-to-1, which it should be.
Yeah, and maybe let's not even put this in the renderer folder. Let's just put it in the components folder if we've got it, or the.
Yep, I think that's right.
Yeah.
Source components.
Oh, that's a very threatening pop up there.
What's that?
That was a very threatening.
Oh, I mean this is the new macOS pop up.
Wow.
Yeah, they take over the whole window, and they're like, which to be fair, the thing that dropped down from here also took over the whole window.
Oh, yeah.
It was just less ostentatious about it.
Oh, okay, I like ostentation.
Yeah. Why is this unhappy? Okay, entity model. It really still just wants to be in a different order.
Dean says he hates the new pop-up.
Yeah,
there's one viewpoint in bucket.
I mean, I gotta say, I'm not a huge fan of most of the new UI changes. I think they feel slower and clunkier.
Interesting. I like Finder. I've only seen Finder just basically from what you've shown me because I'm still on what am I on? Catalina? What's the one before? I don't even know what I'm on.
What am I on? What do they call it? Is it Big Sur? It is Big Sur now.
Yeah.
Yeah, it's it's okay, but also having to make these states more visible when you hover is I don't know. There's just a lot of design I got questions about in here.
Yeah, it does seem a little clunky, doesn't it? They even like to talk about the sin of making the menu bar items wider.
Wider? Oh, wider. Oh man, right? Yeah, it's really bad. They this space is 20, 30 pixels more than there before. I had to pare down half my menu bar items, which
yeah,
it's spring clean anyway, but ugh. I guess they solved it by putting everything in this.
How did you hide your Alfred? I couldn't figure out. Do you need Power Pack to do that?
No, you totally don't. I thought Alfred was in appearance, options, hide menu bar icon.
Oh,
that's your Power Pack tip for the day.
Yeah,
I had to Google it. Because nobody needs an Alfred menu icon. There's not even any icons in this thing. Because
so Dean has a theory that they actually added the extra space to force you to pare it down. to disincentivize
that's so
the
Apple of
addition
them.
of those things. Yeah, but I had a bunch of BS in there, right? I had like I used Carabiner to do like some like keyboard overrides and stuff, and like I definitely didn't need that hanging out.
It's true, but also like I can't get rid of this one. I'd love to.
Oh, magnet.
Yeah,
Yeah,
I don't actually
would
want it
say
here.
that magnet is not necessary to have up there. It's nice
But
to
does
know that
magnet
it's running.
does magnet let me choose? Actually, now that there's an entire menu bar as preference pane, I'm going to check on magnet. No, it's not even in here. This whole thing is a mess.
Okay.
Yeah, no, I'm with Dean. I have a lot of gripes. I'm glad they changed this from like the cartoon version they started with. That's the only upside in this design is they showed us a much worse one and then fixed it.
I kind of want to open my Mac now and just like look at what my UI shows me.
macOS Big Sur battery icon. Have you seen this, Jeff? This was actually very, very funny. Oh yeah, here's the original version.
Oh, you're saying they actually had to like hotfix this?
This was like the first beta, and they were like really excited about the UI, and everyone was like, "What happened?"
Yeah, that is that's programmer art right there, right?
It's I think it's programmer art, but like, I don't know, man. Maybe just don't redo all your glyphs in one go.
Wait, so does the green stuff in the battery actually does it change its width as your battery?
Yeah. This is powered by the ooze that made the Ninja Turtles.
Oh, gosh. There is like a fair amount of skeuomorphism leaking back into the Apple system, right? Like, and this is actually what I would consider to be like kind of bad skeuomorphism.
Like
they actually like drew the battery.
Look at this sound icon.
Right, we're starting to get depth again.
Yeah, but like in a very strange way.
Dancing on Johnny Ive's grave.
Yeah, I think I bet he was sick of fighting the no skeuomorphism fight and maybe just left.
That was the hill he died on, skeuomorphism.
Can you imagine him having to like fight Steve Jobs for 10 years about like, should we do faux leather in our contacts app or not? I'd quit eventually.
Yeah, I don't think I could work for Steve Jobs.
I definitely could not.
Yeah.
I am not made of the stern stuff necessary.
Yeah. Did you watch *Halt and Catch Fire*?
No, I really should. I've heard that's excellent.
It's super awesome. I love it. I actually just read a book called *Masters of Doom*, which is about I'm on like a like game developer's biography kick right now. So I read Jordan Mechner's memoir, and then or rather his like journals, and then I read *Masters of Doom*, which is about the early days of id Software. So it's like John Romero, John Carmack. And that book seems more an inspiration for *Halt and Catch Fire* than like Steve Wozniak and Steve Jobs. It's good.
Interesting.
Yeah. Wouldn't want to work for id Software either.
I mean, I feel I would never have been cut out for any of these startups, really. At the end of the day, like, I don't know. I think they shoot up and spit out a lot of people. So I'm grateful that I missed it.
Yeah. I think we need to do a fair amount of work to get that new table in there. Did you write a clone function already?
I have not. But since we're not modifying it, nothing should clone it? Question mark? I was going to try to get it to render again and then do that.
Yeah. Okay.
Because I think I just need to take render.
The renderable is an interesting one because it's not really simulation dependent. I'll have to think about that one. I think we can treat it the same as any other component, but I don't think it's exactly the same. Like we don't need to roll back the renderable, I don't think. And instead of renderable V2s, can we rename that property to entity models?
Yeah, let's do it.
Yes, I love this.
Entity model.
And then the rollback might screw us, but we'll see.
We shall. I'm not super worried about the rollback.
Well, if we don't clone,
since we're not modifying yet, I think we're in a safe spot for that. Right? Or am I totally whiffing?
well, what are we going to restore the renderable to if we don't clone it?
Oh, I kind of assumed it would just do a bad, like, it'll be making
it'll
a
just
copy of the
object.
pointer.
Yeah.
Right, it'll copy the thing it shouldn't copy, but like it'll be fine. Until we want to change it, at which point it'll stop being fine.
Yeah, and even then it might be fine. You're right.
Okay.
We pluralize that?
Yeah, cool? That's I was making sure I had all the.
You can do rename symbol, dude.
Damn it. You're correct. Okay.
Oh, whatever. You got ahead of steam. Who am I to criticize?
No, you're good. Because this is model and then model.name, and I think this is all we need to get v2 working.
I think you're right.
Is model scoped? Oh, I wonder if model is actually already used here. I'm just going to let it be super specific. Okay, I think that might actually work. Maybe not.
Oh, it's just we're missing. We have to call it model : entity model.name.
Oh,
or
thanks. Yeah. Right.
Is it model name? What does the thing actually expect?
Oh, this was model ID.
Oh, okay. It shouldn't be called ID. ID is a bad word for that.
I mean, this is technically the model ID, I guess, or it's the model name.
Yeah, I think whatever we call it, we should just be consistent on like if is it a name or an ID? You know, like what is it?
Yeah, totally. Entity models dot set. Oh, is this because it is a component table? Why is this unhappy? Has no initializers. Yep, that sure checks out.
I see. Yeah. Are there any other warnings? Because I think there are a couple other places that we want to make that change. Yeah.
Oh, thanks. Good call. Okay, let's see about that.
If we assume that entity models is write only for the purposes of the simulation side, meaning it's read by the renderer, but it's only written to, then I think we can probably exclude that component from the whole rollback regime entirely, right? Because the simulation will just set the renderer properties whatever it wants, and we don't care about the rollback.
It does. I see. Right, because it comes in via commits from the server with player input messages,
Although
but not
we do
actually
need to destroy the renderable if we don't want it to render, though, right? We do need to, like if we accidentally predicted the creation of an entity and then decided that was wrong, then we do need to remove it. So okay, it has to participate in it.
Yeah. Okay.
All right.
Unknown model undefined. Great. That seems fine.
Yeah, that's great.
Let's look at player index. Really? I mean, I feel like I didn't actually do much here. Constant log model. Let's just look at the whole thing. There'll only be one entry in this whole set.
Is your launch.json not set up for breakpoint debugging?
I've never had my launch.json set up, no, which is to my own chagrin.
Are we not committing it to Git?
Yeah.
All right.
Man, was it just like multiple versions behind. Who the hell knows?
I feel like there's something with our auto builder that makes it like one build behind or something.
I'm like a
for the
rapid
client
fire
side.
saver. Yeah, I save a lot, and I think I might hurt it.
I do the same. Yeah.
Okay. Right, because it's actually still. Oh, it's compiling out my console.logs. That's great. Okay. Beautiful.
All right, that works. Wonderful.
It works. We got it. So this was all in the service of getting modifier in there. We should have a clone function. You're totally right. Do we have like a default that's just deep clone, or do I need to?
No, this is fine. I actually don't think we need to clone it. I think you're right if we just copy.
Okay. Even if we start putting modifications here, I guess like we're not predicting anyone else's movement. Yeah, what you're saying. Okay.
What I mean though is like as long as like we don't care about the previous state in the simulation at all. As soon as we do start to care about that, then we should clone. Okay. But it's just for it might be good to like when we come back, we'll come back around off stream and like put a comment there that says like maybe we should clone here. But
yeah. Should I at least write? Should I give it the? Oh, it has the identity one. Okay.
Yeah, you can just do / should we clone to do should we clone ? Like and then we'll at least know.
Great. Yeah. Great point.
But I think as long as it is right only from the point of view of the simulation, as long as whatever updates it runs during that frame, then it should be fine.
So let's see. Our shooter, we have an angle.
Yeah.
And I guess we're really just, we just need to get, oh, is this how it works now? We're just replacing? That's delightful. It's been a hot minute since I've touched an entity.
Yeah.
And then I guess I can get it.
Yeah. So what's going to make this a little bit complicated is that when the renderer applies the rotation, it's going to be a rotation that is stacked on top of the rotation of the main body of the tank. And we do spin the main body of the tank when you're driving, which means that we have to compensate against that. Well, you know what? Let's just do it the direct way right now without compensation and just see if the turret spins without driving the tank. And then
yeah, okay. I guess it's it's a bummer. Yep. Okay. Yeah. And this is going to be name is entity model.name. Oh my gosh. Put the exclamation point.
Yeah.
And then let's look at our. So I guess I'm going to splat the existing modifiers. I'm just trying to think of this from a future.
Can you remind me, does update, do we have to like pass in the entire thing, or I don't even remember. Oh, it can be a partial. So.
Oh, no shit. That's cool.
Yeah, we do object at a sign.
It's just doing object at a sign.
Yeah, this is great.
Yeah. That's super good. Is not assignable to partial.
This modifiers is a key value. So that should work, shouldn't it?
That I would hope is okay. Let's see, entity model dot. Oh, is it that it's singular?
Immutable, yeah. I think it's that it's immutable.
Oh. How do I interrupt that? Oh no, it's that its modifier singular.
Oh.
Yeah.
The player index is now probably broken.
Yep. I was gonna say we really don't even need to set that there then if this is. Well, I was trying to avoid dealing with all the optionality on that chunk of it too.
I get what you're saying.
Declared, but its value is never read, and this is because I misspelled it. That's why Annie is unhappy. Great.
Yeah, copying out
And
of
now it's
immutable should
unhappy
be
that it's
fine.
immutable.
Oh, really? Is not assignable to
Yes.
mat4. Okay.
Oh, well, I know how to fix this. Just make this an immutable mat4. We've done that before, right? We've had to.
Yeah, that actually should be fine.
Mhm.
I'm not convinced that it'll solve the problem, but we'll see. Did it?
It solved this problem, yeah.
Oh my god, TypeScript is crazy. Tank dot
I know.
body dot turret, I think.
Great point.
And we can mess with the actual architecture of that in Blender, right? It's going to be from rotation, mat4 from rotation, maybe.
There we go. From rotation, and this is mat4.create. And then our orientation, our new angle actually is in radians already, isn't it? I think so.
Yeah.
And axis y is up. Y?
It is positive y, yes.
Positive y.
This is a very surprising interface. But
why is that?
Because I would have thought it would take a quaternion. mat4 from rotation translate scale takes a quaternion. I don't know why this one.
I guess maybe because this. Yeah, that is interesting, isn't it?
Yeah, why do axis angle for one and quaternion for another? It's very strange. Anyways,
take it.
What is new angle? How is it calculated?
Let's see. We've got this whole get angle.
All right, we may need to negate that. I don't remember specifically, but let's just
we shall find out.
Yeah, we'll find out. Yeah.
What are we blown up about? Is it
just trailing
commas? Comma. Oh, yeah, gotcha. Man, I thought I set up ESLint and it's not doing it. VS Code. Okay, still nothing, but we need to apply these modifications now.
Exactly, yeah. I think the network's gotten a little bit chuggier for some reason.
Yeah, you feeling some chug? That's
yeah. But you know what? It could be any number of computers between you and me, right?
I was gonna say, yeah, how many computers are going on here? I'm gonna kill Blender. We don't need Blender.
Yeah.
That seems like a safe way. I'm gonna kill the GLTF and Safari while I'm at it.
All right.
All right, excellent. So we want to go to, let's see, we've got our 3D renderer.
Yeah.
So, and then render node, render mesh, all this stuff basically.
Yeah, so
but we need to pass the entity all the way down here.
Yeah, I think basically for render v2, maybe we can take a modifiers object that is the same type, and it may be at a point now where it's worth making that an actual type.
Oh, gotcha. Yeah.
This thing, yeah. Modifiers, yeah, perfect. Actually, you know what? This might be a thing that we define we export from the renderer. Actually, if we can put it into render common, that might be a good place for it.
Okay. Render common.
Although I hope this doesn't get us into trouble with the server side.
Yeah, it's probably fine.
The reason why I bring that up is that like currently this file only includes stuff that's run on the client side. And so things like WebGL buffer is defined in the client side, but inside Node.js, it might not work, but we'll see.
Mm-hmm. Okay.
We'll see. Okay.
Sweet. Yeah.
I think now client render manager.
So then, yeah.
Whatever renderables 3D v2 is also needs to include the modifier. Yeah.
What the hell is this? Where does this come from? Is sort of my.
It comes from client sim.
Oh, okay.
Or no, render manager maybe. Well, there should be a get renderables in client sim. Yeah, and then the next one. Yeah.
Okay. Great. And this is model modifiers is entity model dot modifiers.
Yep.
We're okay. That feels like we're in the right spot.
Yeah, I think we need to add it to the interface too to get that to stop complaining.
Oh, absolutely. I just wanted it to.
Yeah.
Modifiers. I don't know why, but I feel string.
And
you got to come in from common.
Do we fold the model world matrix into that? We shouldn't. We shouldn't, because that is derived from the transform.
Yeah, that's a different thing.
Yeah.
Okay, cool. So then fires. Okay, that's in there, and then draw model is gonna be unhappy. Oh, where is this coming from?
Render v2. It's an anonymous function, so it's a little bit deep. Yeah.
Mm-hmm. But do I need to? Let's see. I need to retype this. Yeah, gotcha. Okay.
It's just all drilling holes. That's programming.
For serious. Okay. And this comes all the way down here. All right. Cool.
So now how this applies to render node is going to be very interesting.
So render node is recursive, right?
It is. So if you're thinking what I'm thinking, we basically strip off pieces of the path as they match the current node or not match the current node. Does that make sense?
Oh, dude, that's much cleverer than what I was thinking. I was thinking we'd have to actually pass down like the current tree recursively. I like yours a lot.
Oh, that's actually totally fine as well. Like what you're saying is like let's pass down the current path. That might actually be simpler. I don't know.
Yeah, I guess I was thinking like we have const path equals prev path plus node.name.
Yeah, exactly. So I think basically render node takes another parameter called parent path. That's a string, right?
Yep. Yeah, parent path equals that. We start off correctly. Oh, oops. That's our input. And then this also needs the modifiers. It does.
Yes.
Oh boy. Path gets passed down in the node. And then modifiers. I'm doing this in the same order on every one of them, but
it doesn't matter.
We'll
just force it. Yeah.
Yep. Just say out loud. I maybe would put model to world first if I hadn't started doing it this way.
It's cool. I think at a certain point this is going to get long enough where a key value object starts to feel better, right?
Yep.
Yeah.
Yeah, actually, it'd be really nice if we just had this, parameterized down in one spot, because, well, except for this one. Okay, we're still rendering. This is great.
Okay, haven't broken anything. It's always a good sign.
I think we actually broke it and then just fixed it.
Okay, nice. What's the one problem that we have according to the linter? Oh, it's just formatting. Just prettier.
Prettier. Fix it. All better. Okay, so back into render mesh. So I feel like if we have the node mesh, then we're looking for model modifiers dot path or mat4.create. I mean, that's a little weird, but this is
so maybe what we can do is we can say if object if object that has a property, and you have it in the right location actually. I think it's in the mesh.
Okay.
Oh, you know what? It's actually you had it. I think it needs to be between.
Just in between, yeah.
I actually think it needs to happen above line 307.
So we do it before we do the transform for the sub.
Yeah, let's say you had all three. You had the model to world transform coming from the parent. You had a local transform on the mesh, and then you had a modifier. I think the modifier is in smack in the middle.
Okay.
Because the local transform is its position relative to its parent. And then you want to further modify that using the modifier. And then you want to apply... Well, what is the stack looking like? I think the way that I described it is correct. But basically, your parent is moving you. Like, it's basically what are the frames of reference, right? You're like, your parent moves you, which is the model to world matrix. Then you have a relative position that you always had to your parent, which is the node.transform. And then you... Oh, yeah. I mean, you're basically kind of like, I think, writing what I was thinking. But, yeah.
Close to it, yeah.
Yeah.
Modifiers.
Okay.
I'm not even sure this code is running.
Okay. That's always a good thing to double check. Parent path plus dot plus. You need to add that period.
That's it. Yep. Let's switch this to
Man, I so go back and forth between like which do I like interpolation or do I like brute force adds?
Yeah, the reason I don't like brute force adds is because it's a not coalescing, coercing operator in JavaScript.
Oh.
Where sometimes you get numbers.
Oh, I see. Yeah, because it adds.
Yeah, it's kind of like it's hard to tell what you're going to end up with.
Yeah.
Okay, so this is not working, which is interesting. I like that the handler took n milliseconds. Oh, I see it's multiple violations.
Yeah.
Oh, and you know what it is? It's I was gonna say it's because this starts out as parent path.
Oh, clever. Yep.
First dot. Yeah. Yep. There we go.
Or we should just require the path to have a first dot.
No, no.
Let's make it slightly ergonomic, is what you're saying. Yeah.
That's the trolliest suggestion, and I kind of love it, but we're not doing it.
I feel like
shit.
Oh, I can't see it.
Oh, I know. Here, let's zoom in. It's rotating just on the wrong axis.
Oh,
but
no.
This is actually great.
Oh, it's rotating around. I mean, we did say Y, didn't we? That's so funny. That's awesome.
I thought I said Y, yeah. But like that's not. Let's go over the shooter system.
It's still really cool.
It's very cool. Let's see. So first of all, this needs to go earlier, like up here earlier.
Oh, because it only rotates when we shoot.
Yeah, we need it not to be on fire, but actually on everything else.
Yeah.
You know what? I am feeling the chunk over here too. I'm gonna kill the server and maybe take a quick peek for Node.
Let's see if we have anything running in the background.
Yeah, I'm just gonna let's get a new tab. Let's get a new that. I see my cores going up over here, and I was just like, yeah.
We should get you set up for with cloud development.
Yeah, I think that'd be worth it. I think I can. Oh yeah, look how smooth that is.
Yeah, nice.
That's exactly what I wanted it to look like.
Yeah.
It's just doing a little dance.
I mean, the fact that it's following the cursor is actually impressive. Like it's kind of like breaking in a way that you like just delightfully did not expect.
It's actually kind of sick. Yeah. Oh man, and it happens correctly for the orientation. It's like I guess it does.
It happens correctly even though we're rotating the base as well. So we got something right here. I think we got our ordering right.
Yeah, I think so.
So
let's
confused.
see. So, what is from rotate? Is Y just not correct for Z? Is the other one I got? I assume it's not X. Let's find out. It certainly doesn't need to be negated. At least not this one.
I wonder if. Yeah, I don't know.
Boom. Now, yeah, when we're backwards is backwards. But when we're facing up, oh baby.
That's very interesting.
Yeah. Look at that. We did it.
Oh yeah, because we didn't do it relative to the rotation of the tank body.
That's correct. And I feel like we maybe apply that here.
Yep, I think that's right.
Because I don't want to teach the renderer about like it shouldn't be like unrelativing the rotation.
Yeah, we should definitely figure out what the issue is with the axes here though, because line 67 is definitely a mystery.
Yeah, let's put a fix me. Why is this Z and not Y?
It makes me think that somehow the maybe we got our order. Yeah, the ordering is not wrong though, right? The ordering looks right. Or
I think the ordering. I think the ordering is pretty good.
Wrong,
yeah,
it would be like doing something really funny.
Yeah, I feel actually great about the ordering. So.
I mean, it's so nice how this worked out, though, right? Like, I think we're like structurally are definitely like in the right direction here.
Absolutely.
And this opens up a lot of possibilities for just animating different parts of different meshes, right?
I think we're doing really great on this actually, because that just looks well. Hang on, I gotta point the tank up for it to look good. That just looks great.
Yeah. And it's finding the cursor really nicely.
I'm a fan.
Yeah.
Nice. Cool. Well,
so all the past 2 days of just chugging away on GLTF were ultimately worth it.
Yeah.
As long as we get textures in there as well.
I was going to say, I think our next task is to get our texture mapping in here so we can make this a sweet cyber tank.
Yeah.
Also, I definitely want like a less Panzer tank looking thing.
Yeah. Are you saying you're gonna model a cyber tank?
I could try to model something. We'll see. I got to decide between Wings and Blender, and also how to learn all that shit.
Yeah. Have you tried Wings?
I have it. I've only like poked at it a little bit, but I need to find a good tutorial.
Yeah.
Get out of here.
I was thinking about doing the whole like video Blender tutorial just so I knew what I was doing.
I think we should both do that. It'll be handy. I love that we have some OBJ models loaded in here too, and it's still just fine. That's really cool.
Which is multiple renders.
Multiple renders. All right. Well, I'm gonna commit this, dude. What number are we on?
61.
Is that it? Yeah. Okay. Oh, we are not doing that.
Do you know what causes that to get generated?
Yeah. Anytime you open a Finder window.
So is that just get ignored? Maybe we should just get ignore it, right?
It should be in my global get ignore. We could certainly put it in our project get ignore, but
yeah,
I consider it a mark of someone screwing up their shit who hasn't set up their get on their new computer yet. Because I just put it in my global get ignore to start. Session 61. I don't know. We're spinning turrets now.
Yeah,
turrets now. Happy New Year.
Love it.
I do love it. That's really cool. Oh yeah, I was gonna say if I go to source Manchester.
I haven't quite figured it out.
I thought it was opening stuff in Finder.
It is Finder related, but I think it's also Spotlight related, perhaps.
Interesting. I don't know. Maybe it's because I just deleted it.
Yeah. It knows.
It knows. It's like you didn't want that.
Yeah.
It could have been that Blender view too. Like Blender might have gone through some strange system.
Yeah, that's a good call out.
Who knows? All right. Well, oops, I killed the server, but the tank is now stuck there forever. Looking off to the left
with a rotated turret, though.
Yeah, wistfully gazing.
Yes, at that core, it can never pick up.
Mm-hmm. All right, sweet. Well, happy New Year's. This has been great. Yep. We did it. I'll see you in 2021.
Yeah, in a few short hours.
It's not that far away. Yeah.
Gosh. Okay. I'm gonna go eat a donut and play video games. I'm probably gonna go play.
Hell yeah!
I'll go play Opus Magnum myself.
Do it. Yeah, you gotta catch up to me.
I'm way behind you now. Yeah.
I know. I'm looking for you on the leaderboards and not seeing it. So bring it on.
Yeah. The leaderboards are gonna have like it's such a give and take kind of thing, because it's like on the one hand you're like, oh cool, I can see how everyone else is doing, but then you're like, oh, how did they get that? You know.
Well, so I've figured out that the leaderboards show your best for each category, but not necessarily for the same run.
Oh, really?
Yeah, because you can't do minimal space and minimal cost and fast.
I know it's all trade-offs. It's programming.
Yeah,
but
if you do like a best version for each of them, you get your leaderboard will be optimal.
So, but it will show you what your current solution is in all three categories, right?
Yeah, totally. But like what I'll see is your best version for each category.
For other people, you'll see their best in each category.
Yeah, exactly.
Yeah. I generally, because I've been playing spendy. I've just been like, I'm going to spend as much as I can because I want to make the cycle count low.
I really like optimizing cycle count. I think it's much more interesting than the other two.
It is. Yeah.
Yeah. It's the one that feels programming.
Yeah, exactly. Code is cheap.
Yep.
Okie doke. Well,
all right. Thanks for hanging out, Dean and Just Okay, if they're still there.
Yeah. Yeah, thanks. And we'll see y'all on Monday night in the new year. Stay safe. Happy New Year.
Night.